Here is a linear motion example. So I want to go over a few things here. The integral parts of linear motion are not going to be included in this year's exam, but the derivative portions will be. So I want to quickly go over that. Here's the question. A, it says, find the acceleration of the particle at time 2, and it wants to know if the speed is increasing. So this is a legitimate question because it only deals with derivatives. Take my graphing calculator and do this problem entirely with the graphing calculator, I would say. Type in the function. Negative x plus 1 sine x squared over 2. Remember, your calculator must be in radian mode since we're dealing with trig. Now the acceleration at t equals 2 is the derivative of velocity at t equals 2. So you just hit second calc 6, type in 2, and that is your answer. So you would write it just, here's all the work you would need to show. V prime of 2 equals 1.587. That's it. Now it's asking, the next question is asking, is the speed increasing at 2? Well, the speed is only increasing when velocity and acceleration have the same sign. So we've already determined that v of 2 is this, or v prime of 2 is this. V of 2, you can see that it's negative by the graph, because that's the graph of v. I can say is less than 0, or maybe just write down the actual value. You just go second calc value at 2. So negative 2.7. Since they're different signs, the speed is decreasing. So to answer the question, is the speed of the particle increasing? No, the speed is not increasing at t equals 2 because v of 2 and v prime of 2 have different signs. That was question A. Question B. Find all times where the particle changes direction. So this is another question that we can handle with just v. We don't need integration, so it's legitimate. They can ask it. Here's the graph of v. It says find all the times between 0 and 3. You can look at this graph and you can see that it changes a lot. So I'm going to change my window from 0 to 3 just so I have a better idea. 0 to 3. Regraph it. And now look very closely at it. It definitely changes directions right here. That's where the velocity goes from negative to positive. So I'm going to calculate that 0. Left bound, I'm good right where I'm at. Right bound, here. Enter for a guess. And it gives me 2.507. E equals 2.507. And does it go through here? I'm not sure. I'm going to take my calculator. I'm going to zoom in once just to check. In right here. Doesn't look like it goes through. You can investigate further by looking at the table, but that's it. So I'm going to answer this question like this. Make sure you provide some justification for that. So justify your answer. Right now I'm going to say because this is where V of t changed from negative to positive. C, find the total distance traveled. Well, we'd have to integrate that and integrate the absolute value. On this year's free response question, they will not ask that. As a matter of fact, the only way to find the total distance traveled with derivatives is you'd have to be given the position function. And I'm going to show you that in a separate video. So during the time interval 0 to 3, what is the greatest distance between the particle and the origin? Well, the distance is going to be dependent on the position. So again, you'd have to go to integration to get that, which is not going to be asked. So that's it for this.